Here we go. Little sound check. Little sound check. Hold on. Do sound check in a second. Can see the levels going up now. Oh, turns up as well. Let's get a quick sound check and then off we go. Pretty sure it's fine, but always check. Hold on, let me find it. Here we go. Check. Sound check. Yep. I mean, the sound's on, but it sounds a little bit bitty actually. Hold on. Let me check. Oh, it's not actually picking up my. Is this right? Let me check the sound looks really off. Hold on. Let's see what it sounds like. I mean, it sounds on, but it sounds a little bit V actually. Hold on. Check. Yeah, it doesn't sound right, this at all. Check it down outside now. It's too sensitive. Okay. I think it was unplugged at the top. So let me check it now. It's definitely on, picking up the wrong speaker then. There we go. That should be much better now. Let me test that it's right. There we go. That should be. It's unplugged at the top. So let me check it now. It's definitely on, picking up the wrong speaker then. There we go. That should be much better now. Let me. Yeah, that's much clearer. Right, that's sorted now. So it means we can get on with the show. Okay. Here we go. I think I got it. Yep, here we go. Right. Everything's rocking, everything's rolling. Twitch is not there, but oh yeah, it's there. Hooray. Okie dokie. So I don't know why my Linux machine's got the constant spinning of doom. But oops. Hold on a second, I'm just turning you guys away for a second. Right, we'll leave that for now. I'll update this another day. Sort it out. Okay, so we're on chapter 6 out of 10 for what was this course again? We are on Learn HTTP Clients in Go. So we're on 14. So yeah. So we finished this tonight because we got through the majority of it anyway. So let me just refresh here, make sure we're logged in. We're on lesson 4 and we're doing HTTP methods. Then there's paths, HTTPS, errors, and curl. So let's just crack on. We need to get through this tonight. Got to finish it. So post requests, and HTTP. I think it's meant to be a HTTP post request sends data to a server, typically to create a new resource. So adding a body. Sorry, I just got distracted by something. The body of a request is the payload sent to the server. The special content type header is used to tell the server the format of the body. Application/JSON for JSON data in our case. Post requests are generally not safe methods to call multiple times because that would create duplicate records. For example, you wouldn't want to accidentally send a tweet twice. Like http.get, the standard library's http.post function could be used to send simple post requests. The trouble is it's a bit limited, and because we need to add an XAPI key header, the simple http.post function won't work for us. Instead, we need to use http.newRequest. So we got a comment in a struct, an ID, a user ID, and a comment. Okay, so we got create comment, API key, comment struct, so you get the comment in there. Returns two things, comment and an error. So encode our comment is JSON, so JSON Marshall comment structure. If there's an error, return the comment as it was and the error. Create a new request. Yeah. New request post. Okay. Set request headers. So request header.set and the API key. Create a new client and make the request. Okay, so we formed the request that we want to send, and the HTTP client is made. Then we do the request and then see what happens when it comes back. And then we always close the body at the end of the function when the function finishes executing, whenever that might be. Decode the JSON data from the response into a new comment struct. Decode is equal to take the response of the body. Okay, so complete the create user function. It should take a URL and API key string and user data as parameters. So it already has that. Encode the user data using JSON Marshall. This is going to be this bit. So it's going to be data. Create a new post request using HTTP new request. Use a bytes.new buffer to create an input-output reader from the JSON data. So it's just the example up here, basically. So then JSON data is there. So create a new post request using HTTP new request. Use a bytes.new buffer to create an input-output reader. Yep. Modify the request headers, so set the content type header to application JSON and X API key to the API key as its value. So that's the same as these two lines. And then make the request using the HTTP client's do method. You can create a new HTTP client or use the http.default client. And then it's going to be decode and return the response's JSON body, which is also a user. F&T employed but not used. Huzzah! Next one. So status codes. The status code of a HTTP response tells the client whether or not the server was able to fulfill a request. Oh, have I got any potions I can use? Yes, I do. Potion. The status code of a HTTP response tells the client whether or not the server was able to fulfill the request. Status codes are 3-digit numbers that are grouped into categories. 100 to 199. Informational responses, these are very rare. 200 to 299 are successful responses. Hopefully most responses are 200s. 300 to 399 are redirection messages. These are typically invisible because the browser or HTTP client will automatically do the redirect. 400 to 499, which is client errors. You'll see these often, especially when trying to debug a client application. 500 to 599, server errors. You'll see these sometimes, usually only if there is a bug on the server. Here are some of the most common status codes, but there is also a full list here. Is this going to be HTTP cat? Kitties? Nope, it's not. If you're interested. 200, okay, this is by far the most common code. It just means that everything works as expected. 201, created. This means that a resource was created successfully, typically in response to a post request. 301, moved permanently. This means the resource was moved to a new place and the response will include where that new place is. Websites often use 301 redirects when they change the domain name, for example. 400, bad request. A general error indicating the client made a mistake in their request. 401, unauthorized. This means the client doesn't have the correct permissions. Maybe they didn't include a required authorization head, for example. 404, not found. You'll see this on websites quite often. It just means the resource doesn't exist. 500, internal server error. This means something went wrong on the server, likely a bug on their end. Don't memorize. It's good you know the basics, It's good to know the basics by heart, like 2xx is good, 4xx is a client error, 5xx is a server error, but don't memorize all the status codes. They're easy to look up. Yep, there we go, HTTP cat. Whoops. Here they all are. Oh, transformation applied. Like that one. Oh, you're a web developer. Name all the HTTP status codes. There's a little video here.
You're probably already familiar with the infamous 404 page, and maybe even status code 500. HTTP status codes are just 3-digit numbers that we've given a specific meaning to. They tell us about the results of our HTTP request. If everything went well, we'll get a 200 level code, maybe a 200 or a 201. If the server thinks we, the client, screwed up the request, we'll get a 400 level code in the HTTP response. 400 is just the generic bad request code. 403, on the other hand, means we're forbidden. For example, maybe we tried to upload a YouTube video to a channel that isn't ours. And of course, a 404 means we've requested something that doesn't exist. Now, 500 level codes means the server screwed up. They're a little bit more rare. 500 is the generic internal server error code. It means the server's down or a recent backend deployment might have introduced a bug. It's usually a try again later situation, unless you are the backend developer that caused it. So 200 level codes are success, 400 level codes are client error, and 500 level codes are server error. So what about 300 and 100 level codes? This feels a bit random. Well, 100 level codes are informational. And as a web application developer, honestly, you can mostly ignore them. They're used in lower level parts of the HTTP protocol, things that your networking library will handle. You wouldn't return a 100 level code in the happy path of your REST API, for example. And you shouldn't expect to handle it manually in your front-end code either. 300 level codes are redirects. They're used all the time, but often they feel invisible if you're the client. 301 indicates that a resource has been moved permanently. 307 is used for temporary redirects. As a server, you'll serve them when changing the URL structure of a resource, and as a client, your HTTP library will just handle the redirects automatically, so you usually don't need to worry about them. Now, as a web developer, I do believe that you should know what each level means, right? 100 level, informational. 200 level, success. 300 level, redirect. 400 level, client error. And 500 level, server error. But I would not recommend sitting down and trying to memorize each code individually. After all, like so many things in programming, they're only a Google search away.
Well said, Lane. Now, just out of curiosity, I'm going to see what is Boot.dev's 404 page if they have one. Oh, it's fairly tame. I wonder if they got a 500 one. Nope. Okay, fair dues. Next bit. Okay, the purpose of status code is to speed up the request, not need to send a response body, inform the client about whether or not the request was successful, alter the method of the request. So the third one. Okay, status code property. So the HTTP response struct has a .status code property that contains the status code of the response. Update the get user code function to return the status code of the response. You should get 404 response when the requesting user doesn't exist. So say, I guess we'll return, and what is it? I guess response dot status code. That's it, really. We've got loads of chests open at the end of this. Let's try it again. Okay. Ta-da! Easy peasy. HTTP put. What ones we got left? Put, patch, put and delete. Okay, the HTTP put method creates, or more commonly updates, the target resource with the contents of the request body. Unlike get and post, there is no http.put function. You will have to create a raw http.request that a HTTP client can do. Post versus put. While post and put are both used for creating resources, put is more common for updates and is idempotent. I always have to look up what idempotent means. A HTTP method is idempotent if the intended effect on the server is of making a single request is the same as the effect of making several identical requests. Okay. Post versus, yep, okay, so we read that. Meaning it's safe to make the same request multiple times without changing the server state more than once. For example, post uses Bob, user Bob, user Bob, user Bob, create Bob user, create duplicate Bob user, create duplicate Bob user. Put uses Bob, create Bob if Bob user if it doesn't exist. Update Bob user with the same data, updates Bob user with the same data. So assignment: complete the update user and get user by ID functions. So update user: the update user function takes a base URL, ID, and API key string and data and user as an input. In return, it returns a user an error. It should encode the user data as JSON string using JSON Marshall. Oh, this is where my memory is going to slack. So update user, let me try and get this. Oh, I'm terrible for memorizing. So it's going to be encode the user data. So it's going to be, I guess, request or error colon equals, and is it going to be JSON? Is it going to be JSON dot Marshall? Hold on, it's going to be JSON data. JSON Marshall like that. If error is not equal to nil, then I guess return user like that, and an error, and then I can't remember the syntax. It's already gone. No. Let me look. Okay, I got the first part right. Yay. Right, so the second part, I'm going to type it out. I'm going to not be lazy and type it out. So next we're going to make the request error. It's going to be equal to http dot new request. It's going to be put, because that's what we're doing, yeah. Put full URL bytes dot new buffer. That's going to be the JSON data. Is there anything else I need? Base URL, ID, API string, blah blah blah, like now. So I guess if error is not equal to nil, then return user error. And then what was the next bit? So what have we done so far? So we did that. 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 And then modify the request header. So I'm going to type it out, try and get it into my muscle memory. So request dot header dot set. It's going to be content type equals application / JSON. XAPI key. So another header, so we're going to do request. So request dot header dot set, and it's going to be x dash API. Is it like that? Dash key is going to be API key, and then we come back to here. So I'm just going to try and remember it off the top of my head. So make a request using HTTP client's do method, you can create a new HTTP client or use the default one. Right, so then I guess we're going to have the response and the error from HTTP client. What's the syntax of client? Oh, so we create it first, right? Okay. All right, let's see. So we create a client with a reference and the response error equals client.do. We do the request. Then if there's an error is not equal to nil, return user error. So defer rest.body close. Right, let me see if I can remember the syntax off of the back of it. Do that, then decode and return the responses. The response is JSON body, which is also a user. Nope, this bit I can't remember in the slightest. So I guess var, and what is it? User, var user. So we create a decoder. We use JSON dot new decoder. We pass in the response dot body. Then error equals decoder dot decode, and then we pass the client reference. No, sorry, we pass the reference to created profile, and then if error is not equal to nil, return user sewer user error. Otherwise return user, hold on, I'm going to call it created user. Created, oh, it's going to be updated user, isn't it? So updated user. Updated user. The user nil. Okay. Oh, 1 minute. Right, important job of the day done. Sorted. Right. Where were we? So, we've got that sorted. Now we've got get user by ID. So it takes a base URL ID API key string and returns a user and error. It should create a new request using http.newRequest. Set the method as get. Set the full URL to full URL. Set the body as nil. So basically the same. I'm just going to make sure you I think this is just basically kind of building rote memory. So we don't need to marshal the data in any way. So we can get rid of that because we're not doing this. We can just set it to nil. So it's going to be get full URL. Modify request set headers. Make the request using a client's do method, and yeah, returns a user. Decode blah 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 and return the user. Okay, I think that's it. Let's just run and see what it does. Okay. Ta-da! Patch versus put. You may encounter the patch method from time to time. It's frankly not used very often. It's meant to partially modify a resource, whereas put is meant to completely replace a resource. Patch is not as popular as put, and many servers, even if they allow partial updates, just use put. Blank is more popular than blank. Put. Put typically updates blank, while patch updates blank. Put typically updates entire resources, while patch updates part of resources. And the last one, delete. The delete method does exactly what you expect. It deletes a specified resource. So this deletes the location with the ID of this. So assignment, complete the delete user function. It takes a base URL, ID, and API key as inputs. You'll need to create a new request, calling like new request. Do the whole same thing as the top. Check the response status code. If the status code indicates a non-successful response, return an error, otherwise return nil. So let's take that. So we're going to take the full URL, delete, if there was no error. Yep, modify the request headers, the XAPI key. So here it's going to be request.header.set. It's going to be x-API, x-API -key is, oh yeah, we do have the API key, there we go, like that. And then we do the request, there is no error, and carry on. If the status is greater than request delete is successful, so that make the request blah 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 blah. Yep. Check the response status code. If the status code indicates a non-successful response, return an error. So we're going to return error. Otherwise, return nil. Return nil. And T is employed but not used, that's fine, just get rid of it. Happy daisies. Woohoo! 7th chapter, 3 chapters left to go. 1, 2, 3, 4. I guess 4 if you can't include it. So, yeah, okay, this should be good. So, paths. URL paths. The URL path comes right after the domain or port if one is provided in a URL string. In this URL, so testdomain.com/root/next. The path is /root/next. Path conventions. Many static websites where the content does not change, as opposed to dynamic web applications, use paths as a direct mapping to the path. Direct mapping to the path to the server's file system. For example, if I was running a static web server for the mystatic.state.com, from the root of my file system, a GET request to mystatic.state.com/document/hello.txt would serve the file at documents/hello.txt for my server. So let's have a little look at this video.
URL paths are something you're probably already familiar with. Take a look at this URL. /courses/learn HTTP clients Golang is the URL path. It's the bit after the domain name or after the port if one was explicitly supplied. Now, a URL path is just a string in a request that the server can use to decide what to serve back in an HTTP response. And the server can do whatever it wants. But there are some strong conventions about how the URL path should be parsed by the server. So let's start with a simple example, a static website. Suppose you have these files on disk. If you run a simple static file server like Caddy or Nginx from the root of this website's directory, it will serve the files by mapping the file hierarchy directly onto the URL path. So if your server is running on HTTP localhost 8080, then 8080/ will serve that index.html file at the root. Now, maybe the HTML inside that page is just big text that says homepage. So that's what you'll see when you visit the URL. But you might wonder, why did I have to navigate to /index.html? Well, it's because most file servers assume that when you navigate to a directory path, in this case, the root / without an explicit file name, index.html is just the default file for that directory. Now, say you wanted to access that contact.html page. Well, you could probably get it with /contact, or maybe more explicitly /contact.html. Though just /contact without the HTML extension is the cleaner convention. And of course, images can also be served over HTTP. So this directory, /images, will likely actually return a 404 not found because we didn't give the name of the file. Some servers might dynamically generate an HTML page that lists the directory contents, but that just depends on the server, which is something you're going to hear me saying a lot. So to load the actual image, we just need to use the full file path, /images/boots.png. Okay, so now we've seen how a typical static file server just maps the URL paths to file system paths. But again, that's just a convention. In dynamic custom web applications, the server may not be serving static files at all. Instead, the backend might return JSON data that it's constructed based on what's in a database. And in that case, the URL paths are probably used to access specific resources. For example, /users might return all the users in the database. And /users/489 might return the user with the ID 489. And in these scenarios, the server decides how each path is handled, and so your only option is really to read the API docs or to be familiar with the backend code yourself to know what's allowed. One final convention worth mentioning is just that URL paths should generally map to distinct resources. Whether those are files, database records, or generated content, different paths should not return the same data, and similarly, repeated requests to the same path should return the same resource, or at least the same types of resources. Query parameters, on the other hand, could be used to sort, filter, or modify a response, but the path itself should be used to indicate the type of thing that's being responded with.
Yeah, well put. So most dynamic web applications don't use this simple mapping of URL path to file path. Technically, a URL path is just a string that the web server can do what it wants with. And modern websites take advantage of that flexibility. Some common examples of what paths are used for include the hierarchy of pages on a website, whether or not that reflects a server's file structure, parameters passed into HTTP request, like the ID of a resource, the version of the API, the type of resource being requested. So the assignment. Fix the get resources function. This is a flexible function that, given a path, makes a get request to the Jello server and returns the response body. Update the full URL. So that that is the base URL, in our case api.boot.dev, concatenate it with its given path. So we'll just do path. RESTful APIs, so representational state transfer, or REST, is a popular convention that many dynamic HTTP servers follow. Not all HTTP APIs are REST APIs or RESTful, but it is very common. RESTful servers follow a loose set of rules that make it easy to build reliable and predictable web APIs. REST is a set of conventions about how HTTP APIs should be built. Separate and agnostic. So the big idea behind REST is that resources are transferred via well-recognized language agnostic client/server interactions. A RESTful style means the implementation of the client and server can be created independently of one another, as long as some simple standards, like the names of the available resources, have been established. So stateless. A RESTful architecture is stateless, which means the server does not need to know what the state of the client is in, nor does the client need to know what the state the server is in. Statelessness in REST is enforced by interacting with resources instead of commands. Keep in mind, this doesn't mean the applications are stateless. What would updating a resource even mean if the server wasn't keeping track of its state? So paths in REST. In a RESTful path, the last section of the path of a URL specifies the resource. For Jello, this means an issue, a user, or a project. Depending on whether the request is a get, post, put, or delete, the resource is read, created, updated, or deleted. The Jello API we have been working with is a RESTful API. Take a look at the following URLs we've been using. So api.boot.dev/v1 /courses REST API /learn HTTP /projects /users /issues. The first part of the path specifies the version, in this case version 1 or v1. The second part of the path tells our server that this is a REST API for the Learn HTTP course. The last part denotes which resource is being accessed, be it project, user, or issue. RESTful servers communicate the state of resources. They don't expose access to arbitrary server commands. Yeah, true. Does a backend server need to adhere to RESTful standards? Yes, otherwise the request will fail. Yes, if it doesn't, it's an insecure server. No, it's generally a bad idea. No, but it's a common convention designed to create better APIs. Just a convention. The blank part of the URL typically denotes the resource, the last part. Okay, URL query parameters. A URL's query parameters, how many things have we got? Okay. The URL's query parameters appear next to the URL structure, but are not always present. They're optional. For example, google.com/search q equals boot.dev. Q equals boot.dev is a query parameter. Like headers, query parameters are key value pairs. In this case, q is the key and boot.dev is the value. Assignment. The backend team building Jello's server has added support for query parameters. The server offers a sort parameter that can be optionally added by appending $sort equals field name to the end of the URL, where field name is the property of the resource you want the response records sorted by. We are creating a job board and want to sort our user records by their years of experience. Update the get users function's full URL with a query parameter that will sort the user's records by experience. Okay, URL plus, and it's going to be sort equals experience. I'm just going to go for it because I feel confident. Ta-da! The documentation of a HTTP server. You may be wondering, how the heck am I supposed to memorize how all these different servers work? The good news is that you don't need to. When you work with a backend server, it's the responsibility of that server's developers to provide you with instructions or documentation that explains how to interact with it. For example, the documentation should tell you the domain of the server, the resources you can interact with HTTP paths, the supported query parameters, the supported HTTP methods, anything else you'll need to know to work with the server. And remember, friends, 6 hours of debugging can save you 5 minutes of reading documentation. Until the next one. The server is the captain now. The server has complete control over how the path. The server has complete control over how the path in a URL is interpreted and used in a request. The same goes for query parameters. While there are a lot of strong conventions around how servers should interpret paths and query parameters, the server can do whatever it wants. That's why you need docs. When working with a backend server, you will need access to blank: the server's private keys, the server's API documentation, the server code documentation. What should you do if the documentation isn't clear about how to use the API? Try and hack your way into the server. Keep trying random requests until you find something that works. Contact the backend developers and ask for better docs or clarification. I mean, I'd try and hack it myself, but let's be pragmatic. Multiple query parameters. So query parameters are key value pairs. That means there can be multiple pairs. So first name, last name. In example above, first name is Lane, last name is Wagner. The question mark separates. Method parameter tracing tree. Not right now, but that sounds interesting. The question mark separates the query parameters from the rest of the URL. The ampersand is used then to separate each additional pair of query parameters after that. Assignment. Jello's CEO has a new idea. They want us to implement a feature that allows users to see the issues with the lowest time estimate, and the number of issues shown depends on the user's availability. Complete fetch tasks function. It should add 2 query parameters to the URL passed to get issues: sort and limit. Sort by the estimate value. Okay, so we're going to say sort equal, in fact, hold on, sort equals estimate plus and limit equals, and then we're going to plus set the value of limit based on the availability. So I guess availability. Oh, is that it? have to turn it into a number. Okay. So it's going to be availability number colon equals I could just do that. And can I do switch statement? So switch availability case case I guess low availability number is equal to 1. Case medium availability number equals 3. Case high availability number equals 5. Is that, I don't know if I've done the switch statement right. Declared not use availability number. Oh, I think, how do you do the, is it like that, string? Hold on. Cast string go go cast type assertions, was it? Go cast, whoops, cast to string. It's just string with the brackets. Go types division into string yields a string of 1 rune, not a string of digits. Go int to string. I mean, to be honest, I could just not. So let's do it like that. Easy sneezy. There we go. Right, we're on to chapter 8. And this is a very short one. This is HTTPS. There's only 4 lessons. Okay. So Hypertext Transfer Protocol Secure, or HTTPS, is an extension of HTTP protocol. HTTPS secures the data transfer between client and server by encrypting all the communication. HTTPS allows a client to safely share sensitive information with the server through HTTP requests, such as credit card information, passwords, or bank account numbers. Assignment. Developers at Jello were prone to making insecure requests, so management has mandated the use of error if not HTTPS function to validate all URL points. Somehow developers still managed to try and use the wrong URL. Fix the bug. Ta-da! Security and encryption. So HTTPS requires that the client use SSL or TLS to protect requests. So let's read. So SSL is Secure Sockets Layer. So Secure Sockets Layer, or SSL, was the old standard security technology for creating an encrypted network link between a server and client, ensuring all data is passes private and secure. The current version of SSL is version 3.0, released by Netscape in 1996, and has been superseded by the Transport Layer Security Protocol, TLS. So let's read what TLS is. So Transport Layer Security. So TLS, Transport Layer Security, formerly known as Secure Sockets Layer, is a protocol used by applications to communicate securely across a network, preventing tampering with and eavesdropping on email, web browsing, messaging, and other protocols. Both TLS and SSL are client/server protocols that ensure communication privacy by using cryptographic protocols to provide security over a network. When a server and client communicate using TLS, it ensures that no third party can eavesdrop or tamper with any message. All modern browsers support the TLS protocol, requiring a server to provide a valid digital certificate. Yeah, okay. So HTTPS requires that the client use SSL or TLS to protect requests and traffic by encrypting the information in the request. You don't need to manually handle encryption or decryption. It's all done for you by the protocol. HTTPS is simply HTTP with built-in security. So HTTP, nothing is encrypted, message is sent in plain text. Message is encrypted, HTTPS, message is encrypted, but yours and the server's identities are not private. HTTPS is not equal to privacy. We won't cover how encryption works in this course, but it's important to understand that what it does and doesn't do, at least in regards to HTTPS. HTTPS will encrypt the data in a request, like passwords, headers, body information, query parameters, etc. You and the recipient are the only ones who can read that information. HTTPS will not hide who you are or that you're communicating with the given user. If you don't want your wife to know if you don't want your wife who knows how to sniff network traffic to know you're using Boot.dev, HTTPS won't help. HTTPS verifies the server. So in addition to encrypting the information within a request, HTTPS uses digital signatures to prove that you're communicating with the server that you think you are. If a hacker were to intercept a HTTPS request by tapping into a network cable, they wouldn't be able to successfully pretend they are your bank's web server. HTTPS is essentially the same HTTP with some additional security. Yeah. And let's see the video. This looks like.
I'm sure you notice whenever you visit a website that only supports plain old HTTP, that your browser gives you a nasty "this site isn't secure" warning. Well, the idea behind HTTPS is really simple. The S just stands for secure, so it's just HTTP secure. But the big two questions that raises are, one, what does HTTPS protect against? And two, what does HTTPS not protect against? Now, this isn't a video about cryptography, so we'll do a bit of hand-waving here, but I still want to cover the basics. When you send an HTTP request and response, the data is sent across the vast infrastructure that makes up the internet in plain text. And that means that the software on your machine, your router, your ISP, the server you're communicating with, and anything in between, they can all read your messages. Now, sometimes that's not a huge deal. Maybe you're just asking for a public web page. But sometimes it is a huge deal. If you're sending a password or an API key or a credit card number, it could be a disaster. And in those cases, we only want the server itself to be able to read our messages. and vice versa. We want to be the only ones that can read its responses. HTTPS solves this. When you make an HTTPS request, the process is a bit more involved. 1. The client verifies the server's digital certificate to ensure it's communicating with the correct server. 2. The client server uses a public-private key pair to perform a handshake and securely agree on a shared symmetric encryption. Then from this point on, both the client and server encrypt and decrypt requests and responses using that shared symmetric key. So this ensures a couple of things. 1, only the client and the server can read the request and response. Even if you're on public Wi-Fi, the router won't be able to decrypt your messages. 2, the client's communicating with the server it thinks it's communicating with. HTTPS isn't just about encryption. It also involves digital certificates and signatures. This means that when you communicate over HTTPS, you can be sure that the server you're talking to actually owns the domain you're requesting from. It's not just some other server pretending to be Google.com. So what doesn't HTTPS protect against? Well, it doesn't keep who you're making requests to private. And this is why VPNs exist. In fact, can I get a sponsorship for this? For example, when you make a Google search over HTTPS, those listening in the middle won't know what data you sent to Google, and they won't know what data Google sent back to you. This is why you're able to log in with passwords. But they will know that you talked to Google and not to Facebook or Wikipedia or any other domain.
Very good. Well put. So HTTPS ensures that you know who you are communicating with. Yep. HTTPS protects your identity online. Nuh-uh. Handling errors. 2 chapters left. Errors and curl requests. I get to open up a load of goodies as well. And I think we're near the end. It's all like small chapters now, which is great because I'm ready to finish off this one. So, handling errors. So when making HTTP requests in Go, it is essential to correctly handle both network errors and non-OK responses from the server. Proper error handling ensures your application can gracefully manage issues and provide meaningful feedback. For the sake of simplicity, all previous lessons have assumed that all our requests have resulted in successful responses. Status codes from 200 to 299. Network errors. So network errors happen when there are problems reaching the server, like DNS failures, connectivity issues, or timeouts. You can detect these errors by checking the error returned by the HTTP request function. Okay. Network error. Okay. Non-OK responses. Even if the request is successful, the server may return a non-OK HTTP status code, so a 404 not found, 500 internal server error. These responses need to be handled separately from network errors. So, say everything's fine like here, but then the status code is not okay. So then there's a problem. A successful response usually has a status code of http.statusok, but it can be any code between 200 to 299. What you should do with a non-OK response from your request depends on you. You may choose to return an error, try the request again, or just log the error. So the assignment, complete the fetch data function. It needs to handle network errors and non-OK responses. It should return the status code, an int, and an error. So I'm going to copy this bit. So let's get that. So we don't need this. We're going to give it the URL. And then I guess we're just going to return, if there's a problem, we're going to return the response dot. So make HTTP requests with the URL. If a network error return a 0 status code and the error. And following the error, and the following error where V is the error value, so network error, okay. So fnt.print line print function that, and then v is the error value, so error dot value like that. If the response does not have a status code 200, return the. If the response does not have a status code 200, return the dot status code and the following error where blah blah blah. If no errors, simply return dot status code and nil. So it'll be return response dot status code and nil. That's okay. This part. Function. It's going to be error dot value. Oh no, it's going to be error state. It's going to be status code, isn't it? So response dot status code. Oh, return 0 like that. Well, yeah. What's the thing? So error interface in Go. Let me see. Let me look at this. Affected Go errors. There you go. Error object. I mean, to just pass the error like that. Multiple value printer. String. Go strings. Go return string interpolation. Sprintf, there we go. Go sprintf. Sprintf. So Spring.dev formats according to format specifier and returns. Why is it called Go? Why is it called Sprint.f? String print formatted. Okay. I don't question it too much. Can it use as error value return statement? String does not implement error. String does not implement error. For network return statement on the following error where okay, hold on. Error. Okay. Errors. So it's going to be errors.new. Errors.new. Right, FFRF formats according to the format specifier returns a string as a value, satisfies the error. Is that what I want? Let's try that. FNT error F. Failed. Whose response does not have... Whoops. Response dot status code. There we go. Right, let's have a look what they used. That's a nifty little thing, that. So error F, so error formatting. Let's have a look at those. Yeah, they did the same thing. I don't even know what the difference is there. Nothing as far as I can see. Anyway, bugs versus errors. So error handling is not the same as debugging. Likewise, errors are not the same as bugs. Good code with no bugs can still produce errors that are gracefully handled. Bugs are by definition bits of code that aren't working as intended. Debugging. Debugging a program is the process of going through your code to find where it is not behaving as expected. Debugging is a manual process performed by the developer. Sometimes developers use special software called a debugger to help find bugs, but often they just use print statements to figure out what's going on. Examples of debugging. So adding a missing parameter to a function call, updating a broken URL, that an HTTP call was trying to reach, fixing a date picker component in an app that wasn't displaying properly. Error handling. So error handling is code that can handle expected edge cases in your program. Error handling is an automated process that we design into our production code to protect it from things like weak internet connections, bad user input, or bugs in other people's code that we have to interface with. Examples of error handling. So checking error values and returning earlier or logging them. Checking if pointers are not nil. Don't use error handling to fix bugs. If your code has a bug, errors won't help you. You just need to go and find the bug and fix it. If something out of your control can produce issues in your code, you should use error handling logic to deal with it. For example, there could be a prompt in Jello for users to update their role, but we don't want them to use punctuation. Validating their input and displaying an error message if something is wrong with it would be a form of error handling. So in the presence of which of the following indicates the developer has something to fix? Bugs. Alright, let's have a look at this video then.
Let's talk about the difference between errors.
Oh, this is an old video, Lane. An old one. And a long one.
So, bugs and errors are not the same. When I first started writing code, I was kind of fuzzy on this whole idea, and to be honest, I think for a long time I assumed they were just kind of the same thing. In reality, bugs are bad, as you probably know. The interesting thing is that errors are not always bad. Not always. Okay? As we've defined them, bugs are kind of unexpected things that are happening in our code. So we want our code to do something, right? Hopefully something useful. And if it's not doing that thing, then we say we have a bug in our code. So bugs are things that are unexpected. To give an example, let's say that we had a function in our code that adds two numbers. Something like add, it takes x and y as inputs, and it produces some result, we'll just call it z. If we called add with 2 and 3, and we got the result of 7, we would say we have a bug. Right? We expected the add function, when given 2 and 3, to produce a 5, but we are getting a 7 instead. That's a bug. It's something that's unexpected in our code. An error, on the other hand, is very often expected. And our job as programmers is to handle that error gracefully. So the way we approach fixing bugs and errors is quite different, right? When we have a bug, really the only thing we can do is go fix the code, right? We actually have to go fix our application. Now, to be fair, there are certain circumstances where fixing a bug might be too expensive, or maybe the bug is there, but it's actually not affecting many of the users, so we kind of ignore it for now. That's more of a business cost decision, right? In a perfect world with unlimited resources, of course, we would always fix all bugs, but the point that I'm trying to get across is when there's a bug, really all you can do is fix code. Errors, on the other hand, sometimes are unavoidable. You can't actually fix the code to remove errors. So, for example, an error that you might get in your code is there is no internet connection. So if you're writing a web app that needs to communicate over the internet to get its job done, and the user's computer has been disconnected from the internet, there's really nothing in your code that you can do to fix that. Right? You can't magically bring back an internet connection. So all you can really do is handle that error gracefully, right? Maybe by showing a message to the user. Another common error might be something like the remote server is down. So you're writing some code on one machine that, again, maybe reaches out over a network to a server or a database, and while you have internet connection, maybe that server is offline. So that's another common type of error that crops up. That, again, nothing's wrong with your code, but it's something that you need to be able to handle and maybe display to the user, something like that. Another common error would be user input. Bad user input. Okay. So maybe you're writing an application that requires users to have passwords over 12 characters. Right? When a user puts in a 10-character password, we might consider that an error. Again, it doesn't mean there's anything wrong with our code, but we need to handle that error and maybe display some message to the user. One final note on the distinction between bugs and errors is that bugs have to be fixed in code. Errors have to be handled in code. Right? So if we expect errors, we must handle them. If we don't handle our errors properly, they may result in bugs.
Good distinction. So, you should use error handling techniques to fix bugs. Wrong. A debugger is required to debug a program. No. Console log the hell out of here. Console log the hell out of here. So install curl. So C curl. curl is a command line tool for transferring data using various protocols like HTTP, HTTPS. It's a favorite among developers. Common other things developers use curl for: quick testing, so make HTTP requests with a single command; automation can seamlessly integrate into scripts and automate automation workflows; debugging, easily see requests and responses. So assignment: most Unix-based systems, including Mac OS and Linux, come with curl pre-installed. Check if you have curl installed by opening terminal and typing this. Whoops. Curl version, yeah. If you see a version number, you're good to go. Run and submit the CLI tests. Ta-da! Curl basics. So the simplest curl command makes a GET request to the provided URL. For example, the JSON placeholder.typecode.com/user/1. The response body is written to the standard out because the output is written to standard output. Standard output is a stream to which a program writes its output data. The program requests data transfer with the right operation. Not all programs generate output. For example, yep, okay. Because the output is written to standard out, you can combine it with other commands, e.g. redirecting the output to a file. Curl supports a number of options and commands, include check their tutorials page or the manual page for more information. We will only be covering the basics. So man curl. So yeah, we look at that. Whoa, very nice. Very nice. So make a curl request to the following URL and look at the response. Make the request again, but this time redirect the output to /temp/issue.json. See that? Oh, so it says no. Oh, sorry. Whoops. Okay, so we're going to do that. And then it's going to be /temp / issues dot JSON. Okay. We're going to submit the CLI tests. Ta-da! Curl post request. So making a post request with curl is almost as simple as a GET request. Use the -x post option to specify the request method and the -d option to pass the data. Okay. So this command makes a HTTP post request to example.com/research with the data of this. The server's response body is written to the standard output. If you need to send JSON data, then use the -h option to set the content type header, and the -d option to pass the JSON. Okay. Assignment: make a post request to the following URL with the JSON data below. So we take this. So it's going to be this. So that. And then this. What I could do is I just put it into there. And that. Then. That. And redirect the response to temp user.json. So then, so temps / user.json. Okay. Then we run this. I'm pretty confident, so we'll just do it straight away. Yay! Install a JQ. So JQ is a powerful command line tool for processing JSON data. It's a favorite among developers who are working with JSON because it can parse JSON, easily read and extract data from JSON responses, manipulate JSON, so modify JSON data on the fly, filter JSON, so find exactly what you're looking for within large JSON structures. So assignment: most Unix systems, including macOS and Linux, do not come with JQ pre-installed. Follow the steps to install it in your system. Check your JQ installed in the terminal. So let's check. I do have it. Okay, so I'll just run the thing. Huzzah. And then the last lesson in this chapter, in this whole thing of HTTP networks with Go, is once you've installed JQ to parse and manipulate JSON data, here's a simple example to get you started. Suppose you have a JSON file named user.json. To extract the name field, you could use this. JQ.name user.json. JQ with curl. So JQ is frequently used with curl to parse JSON responses directly from HTTP requests. For example, to fetch JSON data from an API and extract a field, we can use the object identifier index. What is that? So the simply useful filter has the form .foo. When given a JSON object, aka dictionary hash, as input, .foo produces the value of the key foo if the key is present or null otherwise. Okay. So we kill that and then we say jq.username. To get a field from each element in an array, you can use the array object value iterator.array, which can in turn be combined with the identifier index. So loop over all of them and get .username. Multiple fields. So jQuery is extremely powerful. We won't cover every feature in this course, but it's a tool you should know about for the future. So make a curl get request to the following URL. So curl. So curl that, and then pipe. Use jQuery to extract each type. Use issues title and estimate from the response. List all the titles first, then all the estimates. Redirect the output to that. So then JQ, and what is it? JQ then quotes, then dot an array, then dot title, and then how do you do multiple? You do comma, yeah. So you do comma dot array, and then what was it? Estimate. Estimate. And then that to that. And then final one. Huzzah. Completed. Boom, baby. Right, claim that. 4,000 XP. Yes. Yes. We'll come back to this in a second. Okay. Cost another thing. This course is spot on. To be honest, I can't really think of any areas to improve. To be honest, the only thing I can think to improve is updating one of the videos from the old format to the new for consistency. That's minor and doesn't affect the quality at all, though. 5 stars. I'll submit the review for now. We've got loads of chests open. Yay! So open the chests. Open the chests. Do I get a big fancy chest at some point? I hope so. These all kind of bog standard. Ooh, speaking of a fancy chest, here we go. Don't know what the gold thing means, but whoa, loads of baked salmon. Huzzah! Dashboard. Right, okay, before we do that, we're gonna share this. Hold on. Share on X. I get Here we go. Yeah. I'm trying to think of something to say. It's like based on the lines. So we often don't realize what information, and special, especially, especially if if we don't need to regularly test our test ourselves or use or test ourselves on it. HTTP might seem simple, but there are a lot of layers and specifics we often neglect and forget about. Well, let me look back through the code. So what was the part that kind of like I refreshed myself the most? Whether it's the fine detail of how DNS works, remembering all the segments that make up a URL and their correct names. It's worth refreshing once in a while and testing ourselves on the finer details. I often find there's details I didn't even know about. Another great course by the great course on the amazing Boot.dev. built. I'm slowly starting to build up my Go muscle memory 2. Let's post that. Happy days. Okay. LinkedIn. So I guess Go Pro, language, HTTP, DNS. What else do we learn on this one? I guess REST. I'll do. Next. There we go. Next. Boot.dev. Hey ho, there we go. So, next time we'll be building a REPL Pokédex on the command line in Go. Learn how to use JSON, make network requests, and implement caching. This is going to be cool. 24 hours of content, 12 addicting lessons, earn a certificate of completion, learn online at your own pace. So what will you learn? So, REPL, a read, evaluate, print loop, is a simple interactive programming environment that takes user inputs, evaluates them, and returns results. Learn how to implement one from scratch in Go. Cache, when making network requests, one of the most common performance optimizations is to cache the results. Implement an in-memory cache for the Poke API in Go. And then Pokédex. Bring your REPL and cache together to complete your fully functional Pokédex CLI. This is going to be a good one. So, I'm sold. We'll be doing this next time, Lane. Have I got any more things to open? What's this one? Oh. Interview with Boots. When you need to fetch a filter list of resources from external API using Go's net/HTTP client, how would you decide which HTTP method to use and where to put the filter parameters? Explain your approach and the reasoning behind it. Methods and params choice. Go docs, blah, 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 blah. Key ideas to recall. URL path identifies resource, blah, 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 blah. I won't do that right now, but that's cool that basically testing your knowledge each day. I am in the top daily learners. Top league learners. Global leaderboards. Top community members. I'm never going to go anywhere close to that. I'm on 0. Recent archmages. So, am I close to becoming an archmage? What would it have to be? Like, level 100. What am I on? This is cool. Oops. Oh, it's my picture. I could put that in. Didn't realise that. Hey, there we go. So, achievements. Yeah, so I have to get to level 100. I'm gonna have to ask Lane, like, how do I do that? But anyway, we're doing alright. Building a Pokedex. Guided project, course, SQL, not done that for a while, so that'll be good. Guided project again, course. And file service, CGN's and S3, yeah. Docker, yeah. Capstone project, what is this going to be? So there we go. Sorted. Right. Well, that's going to be it for tonight. We smashed it. So we'll be building a Pokedex next time. And at this rate, it's going to be next week. We're going to have a full 3 days next week to go through it. So yeah, thanks for coming down. Hope you enjoyed it. We smashed out another one. We're getting through these. We're getting close to the end. I don't think we'll realistically be able to complete the deeper learning courses, but it definitely get through the first 23. And after that, it's kind of like, do I really need to go into the other stuff? But we'll see. Anyway, thanks for coming down. Thanks for watching. If you coming back from the future, let me know where you get a time machine from. Hold on a second before I sign off. Goodbyes. Okay. Another. Whoops. These. Okay. Thanks for coming down. Have a good night, and I'll see you next time.